Hi, today for the YouTube video I'm going to explain a hybrid architecture that most of the banking applications that are going to opt this design to create their systems and architecture. So for core transactions, right, for banking systems they will have a core transactions, and other modules may include some notification modules, right? So the thing is, banks need a hybrid architecture. For core banking operations they need synchronous style. For notification alerts and other things they need a synchronous design. So combining these both synchronous and asynchronous design styles, we call it as a hybrid architecture. Okay, so idempotency checking, logging, retry, deadlock queue mechanisms, we can implement this whenever some failure occurs to take the backup of failed records. So I want to explain the final architecture and how this design works for millions of records. You can see we are going to have a client, and client will call API, and the API will include the service which is marked by transaction annotations. We will use transaction annotation inside the service to make it more transactional for multiple requests, because whenever particular transaction failed, it will roll back that either transaction should happen completely or it should be rolled back. That is the transactional statement usage. And we use the stored procedures here. We are not using JPA. See, we are going to write a stored procedure and updating the statements inside the stored procedures, and we will commit it. And after that we will publish an event. As I told you, for alerting purpose we need to publish the event, and the consumers will be there which will consume the notification, and we can actually process the auditing details, or we can use it further. So we need to create two tables, orders table and payments table. Order will contain order details, payment details will contain the payments table. Okay, payments table basically it will contain all the payment table. So idempotency is for we will create some request log table. Okay, for each request we will actually track it, and we are creating a sequence for payments table. And you can see we have order ID, amount. For the procedure, you can see we are taking order ID and the amount, and the request ID, status, message. You see, first thing is we are storing the request ID in the request log, and after that we are actually locking the table, because we need to update the table, right? We are going to lock the table, orders table, so that it will log the corresponding row. And after that we are checking a status. If the status is not pending, then we will update the stored procedure key status and message as failed. And after that we see we are updating the orders table. For this particular order we are telling that it is completed, because you see we are going to update the status as completed for this particular order. And after that we need to insert the payment details into payment table, right? So we are handling some error mechanism. Whenever exception occur, there is a predefined exception class in PL SQL. You can see duplicate value and index. If it is caught like that, then what we are doing, we are setting the status and message both as you can see status as duplicate, message is already processed. In case whenever in any other exception, we are just getting the error and SQL error message code. Okay, now the Spring Boot will have a controller. We are injecting the payment service as auto white, and we have a model. Request model is order ID, amount, and request ID. Request ID is not required, but anyhow we are including it. It's not mandatory. And payment service is auto wiring the payment repository, and inside the repository we are calling a store procedure. If the response of the procedure execution is success, then we are publishing the event. We are publishing the particular request to event, Kafka event. Okay. If the status is duplicate, we are mentioning it is already processed. You can see this is where we are calling the store procedure. We are using prepared call, getting a connection object and then prepared call statement. And we are setting all the input parameters here. Output parameters are 4 and 5. You can see what is the status and message. These are the output parameters. So you can see now, as per the code, if the store procedure call is success and we are publishing an event, and further we need to have a Kafka payment publisher. It is a Kafka publisher, so we auto-write the Kafka template, and we actually need to use a publish method here. Kafka send, and we are publishing the request ID along with the request. And the consumer side, it is reading the message from the topic payment events. We'll read the event, and we're just printing this out here just for simulating it, right? So we can also add a DLQ logic later. If you want, we can create a DLQ config. If something is failed, we can actually log the failed records into DLQ table or some message. Okay. So this is how it happens. You can see it is very scalable. You can see app instance, Kafka for consumers. Okay, consistency will be, scalability will be there. So here what did we do? We use both synchronous and asynchronous. Synchronous for core transaction mechanism, asynchronous for scalability, for notification and alerts. So this is how the real-time banking systems are adopting this kind of architecture. They are going with the both synchronous and asynchronous. So whenever you want to design an architecture for banking application, should be hybrid architecture. You should not depend completely on synchronous system, or it's not completely event-driven architecture. It should be both. So that's how we design the architecture. Hope you understood this. Thank you for listening.